Hello students, today we'll discuss continuity and differentiability. So first we have to know about what is a continuous function here. So what is continuous function means? Suppose any graph you can take, the graph of the function has no breaks. So those type of functions will call it as the continuous functions. Otherwise it is called as the discontinuous function here. Okay. So the graph of the function has no breaks is called as continuous function. Otherwise, it is called as discontinuous function. For example, we say any sin x function. Suppose f of x is equal to sin x function. We know the graph of sin x function always it will be the maximum value is 1, the minimum value is -1 here. Suppose sin 0 is 0 here. We know how the graph is. Okay, like this and so on, it will go continuously here. So in this graph, there is no breaks is there. So it is going continuously. So therefore, sin x is continuous function. And so what is, for example, a discontinuous function? We'll take f of x is equal to greatest integer function here. So how this it will be? We know this is like this steps function will get here. So like this form is there. Okay. Even here also. So like this is, so this graph is a step by step it is there means, and there is a breaks is there. There is no continuous in this one. So this is called as the discontinuous function here. So f of x is equal to greatest integer function is discontinuous function. Okay, so understand guys. So what is continuous function? What is discontinuous function here? So next we will discuss here continuity of f. So continuity of f at a point x is equal to a. So where a is any real number. Okay, so continuity of f at any point x equal to a is nothing but, so same here. Let any function y is equal to f of x is said to be continuous at x equal to a, is said to be continuous at x equal to a. Okay, in the domain if limit extends to a is equal to, okay, limit extends to a, f of x is equal to f of a. So if you will get these two are equal, then we can say that, so through the particular point, the function is continuous here. Or else if you prove here, or left hand limit is equal to right hand limit is equal to f of a. So if you prove this one, so then it will be continuous function. So what is LHL function? Limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to f of a. Okay. If you prove that either this one or this one also, then the function we can say that is the continuous function here. So next here we wrote here LHL and RHL. So what is that one? So one is left continuity. So what is left continuity? Let the function f said to be left continuous if limit x tends to a minus f of x is equal to f of a. Okay. So limit x tends to a minus f of x is equal to f of a. Then that function is called as the left continuity. Next, right continuity is same here. So let the function f said to be right continuous if limit x tends to a plus, okay, limit x tends to a plus f of x is equal to f of a. So then this function will call it as the right continuity here. Okay. So the next one is continuous at a comma b. Continuous at here open brackets a comma b. So continuous at a comma b is same here. So the function f continuous in open brackets a comma b, that is, so f is continuous at so continuous at every point. So between A and B. So here open brackets A and B means excluding these points here. So which means it is continuous at every point between A and B, but not A and B. Okay. So but not the points A and B here. So between whatever points, so it function will be continuous. So that is called as the continuous at open brackets A comma B here. Next, continuous at closure brackets a comma b. Continuous at open bracket, sorry, closure brackets a comma b is okay. Same here. The function f continuous in closure brackets a comma b, that is f is continuous at every point from A to B. So from A to B, whatever point you can take, so that is function is continuous at closure brackets A comma B here. So which means limit x tends to A plus f of x is equal to f of A, and limit extends to b minus f of x is equal to f of b here. Okay. So if you prove this one, then this function is continuous at a comma b will get here. So the next exercise 5.1, the first problem if you see here, prove that the function f of x is equal to 5x minus 3 is continuous at x equal to 0, at x equal to minus 3 and x equal to 5 also. See here, first we are taking given that f of x is equal to 5x minus 3 here. We know first we will take at x is equal to 0. So at x equal to 0, the function will be f of 0 is equal to 5 into 0 minus 3, which is nothing but minus 3 will get here. Okay. Next, left hand limit also, if you will check here. So left hand limit is nothing but 0 minus we have to take. So that is limit extends to 0 minus f of x is equal to, so limit extends to 0 minus f of x is nothing but 5x minus 3. So in 0, if you in place of x, if you substitute 0, so 5 into 0 minus 3 is equal to minus 3 only we are getting here. So next, right hand limit, same here, limit extends to 0 plus f of x is equal to limit extends to 0 plus 5x minus 3 is equal to 5 into 0 minus 3. So wherever x is there, we will substitute 0 value here. 5 into 0, 0. 0 minus 3 is minus 3 only. So here, at x equal to 0, so LHL is equal to RHL is equal to f of 0 we are getting here. So which is value is nothing but minus 3 we are getting here. Therefore, f is continuous at x is equal to 0 here. Okay. Next, same way we will find out for x is equal to minus 3 at x equal to minus 3 here. So x equal to minus 3, we substitute here, f of minus 3 is equal to 5 into minus 3 minus 3 will be. So 5 into minus 3 is minus 15 minus 3. So minus 18 will get here. Next, LHL, if you will check here. So limit extends to minus 3 plus. So minus 3 plus is nothing but, sorry, minus 3 minus the left hand limit function, that is f of x here. So limit f of x is 5x minus 3. So 5 into minus 3 minus 3. So which means wherever x is there, we'll substitute minus 3. So minus 15 minus 3 will get here. So which is nothing but minus 18 will get here. Even RHL also. So limit extends to minus 3 plus f of x here. So limit extends to minus 3 plus f of x is 5x minus 3. Wherever x is there, we'll substitute here 5 into minus 3 minus 3. So which is nothing but minus 8 only. So LHL is equal to RHL is equal to f of minus 3 is equal to minus 18 we are getting. Therefore, f is continuous at x is equal to minus 3. So next one is x equal to 5. So this is x equal to minus 3. This is x equal to 5 here. Same f of 5 is equal to, so wherever f of x is equal to 5x minus 3. So f of 5 will be 5 into 5 minus 3. So 25 minus 3 is equal to 22 will get here. So left hand limit also, limit extends to 5 minus f of x is equal to limit extends to 5 minus f of x is 5x minus 3 is equal to 5 into 5 is 25 minus 3 is equal to 22 here. Even RHL also limit x tends to 5 plus f of x is equal to limit x tends to 5 plus f of x is 5x minus 3 is equal to 5 5 is 25 minus 3 is 22 here. So here LHL is equal to RHL is equal to f of 5 is equal to 22 we are getting. Therefore, f is continuous at x equal to 5 here. So the given function is continuous at 0 and minus 3 and minus 5, sorry, plus 5 as well here. Next, the question number 2 here. So examine the continuity of the function f of x is equal to 2x square minus 1 at x is equal to 3 here. So the given function f of x is equal to 2x square minus 1. So at x equal to 3 we are taking here. At x equal to 3, so f of 3 is equal to 2 into 3 square minus 1 is equal to 2 into 3 square will be 9 minus 1. 2 9s are 18 minus 1 is equal to 17 is the answer here. Next, left hand limit LHL will be limit x tends to 3 minus f of x is equal to limit x tends to 3 minus f of x is 2x square minus 1 is equal to 2 into 3 square minus 1. So 2 into 3 square is 9 minus 1 is also nothing but 18 minus 1 is equal to 17 here. So next one is RHL, which implies, so RHL is limit x tends to 5 plus, sorry, 3 plus f of x. So limit x tends to 3 plus f of x is also 2x square minus 1, which is equal to 2 into 3 square minus 1. So 2 into 9 minus 1 is equal to 18 minus 1 is equal to 17 here. Therefore, LHL is equal to RHL is equal to f of 3 is equal to 17 here. Therefore, f is continuous at x is equal to 3 here. Okay. The next third one is examine the following functions for continuity. The first one is a is equal to f of x is equal to x minus 5 here. So first we are solving here a problem. F of x is equal to x minus 5. So examine the following functions for continuity means we have to check for each and every number the function is continuous or not here. So for this one we are taking here a is any real number. Okay, let a is any real number. So any real number means, so first we are taking here, so at x equal to a. So at x equal to a, then f of a is equal to a minus 5 we will get here. Okay. Next, left hand limit we are taking here. Left hand limit is limit x tends to a minus f of x. So limit x tends to a minus f of x is, so limit x tends to a minus f of x is x minus 5 here. So if you substitute here a minus 5 only will get here. Next, RHL limit is limit x tends to a plus f of x is equal to limit x tends to a plus f of x is x minus 5, which is equal to wherever x is substitute 5a here, a minus 5 will get it. So f of a also a minus 5, LHL also a minus 5, RHL also a minus 5. Therefore, LHL is equal to RHL is equal to f of a is equal to a minus 5. Okay. Therefore, F is continuous at uh, continuous for every real number. Why? Because starting we took here, a is the real number. Therefore, every real number, this function is continuous function here. Okay. Next, second one. So B problem if you see here, f of x is equal to 1 divided by x minus 5 here. So x minus 5, the condition is where x is not equal to 5 here. Condition is x is not equal to 5. So x is not equal to 5 means, so if we take 5, this function is this 1 by 0, 1 by 5 minus 5 is 0, 1 by 0 is not defined. Okay. So here also we are taking where k is, any number, let a is real number in brackets, a is not equal to 5 here. Okay. Then at x equal to a, f of a will be 1 divided by a minus 5 we will get here. Next left hand limit is limit x tends to a minus f of x is equal to limit x tends to a minus f of x is 1 divided by x minus 5 is equal to 1 divided by a minus 5 here. RHL is limit x tends to a plus f of x is equal to limit x tends to a plus f of x is 1 divided by x minus 5 here. So this one also 1 divided by a minus 5. Therefore, LHL is equal to RHL is equal to f of a is equal to 1 divided by a minus 5 here. Therefore, f is continuous at every real number except 5. Why? Because starting we took here a is not equal to 5 here. So except this 5 number, this function is continuous for every real number. Next, the C problem you see here. Here also, the C1 is x is not equal to 5 here. Okay. So f of x is equal to x square minus 25 divided by x minus 5 will get here. So here also we are taking here let a be any real number. Okay. If a is real number means at x equal to a, f of a is a square minus 25 divided by a minus 5 we will get. But here it is in the form of a square minus 25 can be written as a square minus 25 can be written as 5 square divided by a minus 5, which is equal to a square minus b square can be written as a plus b into a minus b. So a plus 5 into a minus 5 divided by a minus 5. So a minus 5 will get cancelled. Only a plus 5 will get here. Okay. So next LHL limit it will take here. So limit x tends to a minus f of x is equal to limit x tends to a minus f of x is same here x square minus 25 divided by x minus 5 here. You substitute a square minus 25 can be written as 5 square divided by a minus 5 will get. So which is equal to, which is in the form of a square minus b square. So a plus b into a minus b. So a minus 5 divided by a minus 5. So a minus 5 get cancelled. A plus 5 will get here. Next RHL limit is same. Limit x tends to a plus f of x is equal to limit x tends to a plus f of x is same. X square minus 25 divided by x minus 5 is equal to a square minus. So 25 can be written as 5 square divided by a minus 5, which is equal to a plus 5 into a minus 5 divided by a minus 5. A minus 5 get cancelled. A plus 5 only will get here. Therefore, left hand limit is equal to RHL is equal to f of a, which is equal to a plus 5 we are getting here. Therefore, f is continuous at every real number. Every real number except here where x is not equal to 5 means here also will take a is not equal to 5 here. So except 5. So except 5, this function is continuous at every real number.